Welcome to another video here on Tobacco University. Here we're going to be looking at Snell's Law of Refraction. Now refraction, keep in mind, light passing through different mediums can cause bending of light. That's what kind of makes the spoon look like an optical illusion here. Looks like it's broken. That's because of the bending of the light through those different mediums. Now, Snell's law of refraction. Well, Snell's law describes the behavior of light as it travels from one medium into a different medium. And Snell's law can be written as N1, which is referring to the refractive index of substance 1, times the sine of angle 1, equals the refractive index N2 of substance 2, times the sine of the angle of angle number 2. Now, both of these angles are measured relative to the normal or line drawn perpendicular, as we can see indicated here, to the surfaces where the two mediums will meet. Now, Snell's law of refraction, in order to calculate this, the refractive index of materials is based on the angle the light hits and bends. We can see that depicted here. The light's coming in at this angle, passes through the mediums, and then it comes out at this angle through the second medium. Here we can see all of the components. Here we can see all of them described. However, to best understand this, let's apply some numbers to this in an actual mathematical equation. So looking at Snell's Law Example number 1. Light traveling in air, which is refractive index of 1, hits a piece of glass at an angle of 30 degrees. The light refracts in the glass at an angle of 15 degrees. The question is, what is the index of refraction of the glass? So what we first want to do is take the components given to us and apply them to the equation for what we know. So how we would go about this is we'd start with the substance 1, the refractive index is 1, that's going to be the air, and it's a piece of glass at the angle of 30 degrees. So we know the angle in substance 1, we know the refractive index. Then the light refracts in the glass at an angle of 15 degrees, so we know the angle. What it's asking for is what is the refractive index of that glass? What's N2 in this example? So if we go back to that equation, we kind of plug everything in. Well, 1 times the sine of 30 equals the refractive index of substance 2 times the sine of 15. So how does that look? Well, 0.5 is going to equal 0.2588 times N2. Solving for N2, we get N2 has a refractive index of 1.93. So what is the index of refraction of the glass? The answer would be 1.93. Moving on to example 2 for Snell's law here. Slightly different example given here. Light traveling in air has a refractive index of 1, hits a piece of glass at an angle of 45 degrees. If the glass has a refractive index of 1.5, what angle should the light bend at? So in this example, I'm giving you now the refractive index of the glass, and I'm asking you now to determine that angle. So just as we did before, you're going to go through, you're going to find out all the information that you know. We know refractive index, we know the angle in substance 1. We don't know the angle the light leaves, but we do know the refractive index. So same as always, we plug everything in. Here we're solving for the angle. We go through the same mathematical process, multiply those, leave that there, factor that down to the next step, get 0.4714 equals the sine of angle 2. Going back and taking the inverse sine there, we're getting that the angle would be 28 degrees. So again, here we're solving for the angle before we're solving for the refractive index. This is kind of both parts of the calculating for Snell's law. Now here we have some Snell's law practice, so I encourage you to pause the video here, take a look at these, grab a calculator, and go through and solve some of these questions, because the answers appear on the next slide, and I will be reviewing them in a moment. So again, here, pause the video, work your way through these, and then compare your answers to the answers provided. Hopefully you've gone through and paused the video at this time, because here I'm going to give you the answers. So here are your answers. Remember, the first two are referring to refractive indexes, and the last two are looking at degrees. Hopefully you got these. If not, I suggest you go back and watch the video again, and hopefully that will help you be able to answer any of these questions that may show up in the future.